Factor each of the following expressions completely. A. 16x to the fourth minus 1. The first thing we always look for is a common factor, and I see that 16x to the fourth and 1 have no common factors. So we're going to have to maybe write this as two sets of parentheses, two binomials. So let's start this way. I see it's got two terms with a subtraction in the middle, so this can probably be written as a difference of squares. So 16 is 4 times 4. X to the fourth is x squared times x squared. And minus 1 is positive 1 times negative 1. Now 4x squared plus 1, that's a sum of squares. Those don't factor, so we can just leave that as it is. However, 4x squared minus 1 is another difference of squares, so we can factor this one a second time. 4 is 2 times 2. X squared is x times x. Minus 1 is 1 times negative 1. These have no common factors. They don't factor any further, so we know this first expression is factored completely as 4x squared plus 1 times 2x plus 1 times 2x minus 1. B. 2x squared minus 3x minus 2. As in the first problem, we look for a common factor and see that there isn't one. So it looks like we're going to have to do this by some other method first. It's got three terms, no common factor, and our leading coefficient is not 1. So we can do this either by the grouping method, arc method, slide method, or trial factors. So I'm going to do this by grouping. This is where we take the first times the last. So 2 times negative 2 is negative 4. I'm looking for two numbers whose product is negative 4 and whose sum is the middle term, negative 3. So 4 could be 1 times negative 4, 2 times negative 2, or 4 times negative 1. If you look at each of these sums, the first two add up to negative 3. These two add up to 0. These two add up to positive 3. This is the only pair, 1 minus 4 is the only pair that adds up to negative 3. That means we're going to group this in the following way. We keep the 2x squared. We keep the last term, minus 2. And we're going to break up this minus 3x as positive 1x minus 4x. Now we do the factoring by grouping. We look for a common factor in the front pair. I see each of these have an x in common, so we can factor out the x. To see what's left in the parentheses, divide each of these by what we factored out. Divide each by x. This leaves us with 2x plus 1. For the second pair, I see each of these have a 2 in common, and we lead off with a minus sign. So let's factor out a negative 2. If you divide each of these by negative 2, I see we're left over with 2x plus 1. Now, big picture common factor, I see these both have a 2x plus 1 in common. So we factor out the 2x plus 1. Once this has been factored out, I see what's left in the parentheses must be x minus 2. So now we have this one completely factored as 2x plus 1 times x minus 2. C. 3x to the fifth minus 48x. Remember, the first thing to always look for is a common factor, and I see we finally have one. These both have a 3 in common, and they both have an x. Let's rewrite the original problem. 3x to the fifth minus 48x. They both have a 3 and an x in common. So to see what's left inside the parentheses, divide each of these terms by 3x. That leaves us with x to the fourth minus 16. Now our parentheses can factor further. This looks like a difference of squares. So we're going to write two sets of parentheses. X to the fourth is x squared times x squared. Negative 16 is positive 4 times negative 4. And then don't forget the common factor of 3x that we took out in front. That's got to stay. Now x squared plus 4 is a sum of squares. That won't factor any further, so we can just leave it as is. But this x squared minus 4 is another difference of squares, so we can factor this again. X squared is x times x. Negative 4 is positive 2 times negative 2. We've now factored this one completely. So we can write this in as 3x times x squared plus 4 times x plus 2 times x minus 2. D, 125 x to the 6th minus 27 y to the 9th. The first thing we always look for is a common factor. Only 5 will go into this front term, but 5 doesn't go into the last term, so that says these have no common factor. I see that each of the exponents is a multiple of 3, and each of these numbers out in front are cubes. So we're going to use the sum or difference of cubes formulas. To remind you what this is if you have a cubed minus b cubed, we can factor this as a minus b times a squared plus ab plus b squared. Now, all that's left is to identify what is a and what is b, so we can factor it using that formula. A is the quantity that when you cube it gives you 125 x to the 6th. So a must be 5 x squared, because if you cube 5, you get 125. If you cube x squared, you get x to the 6th. B is the quantity that when cubed gives you 27 y to the 9th. So b must be 3 y to the 3rd. Now that we've identified a and b, we're ready to plug it into our formula. So this is a minus b, so 5x squared minus 3y cubed. We've now done the first half of our formula, times a squared. Well, if we square a, we get 25x to the 4th, plus a times b. A times b is 15x squared y to the 3rd, plus b squared. We're now going to square b, which will give us 9y to the 6th. Now we've got this one factored completely. Finally, part E. 16x cubed plus 2y to the 12th. The first thing we always look for is a common factor. And I see that 16 and 2 both have a 2 in common. So the first thing we do is factor out the 2. To see what's left in the parentheses, divide each of these by what we factored out. So divide by 2. This gives us 8x cubed plus y to the 12th. This, we can now apply the same formula we did in the previous problem, other than the minus sign. We had a subtraction sign here. We have an addition sign on our problem. So there's one minor modification we're going to make on this formula, and this is that a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. So one way to remember how the signs go is that this first sign is always the same as the original problem. This is opposite of the original problem. This last one is always positive. Let's now use that to identify the factors in our problem. A is the quantity that when cubed gives you 8x to the 3rd. So a must be 2x. B is the quantity that when you cube it, you get y to the 12th. So b must be y to the 4th. Let's now plug the a and b into the formula in blue. So the 2 will just stay out in the front. And now we have a plus b. So 2x plus y to the 4th times a squared. We now square the a, which is 4x squared, minus a times b, 2x y to the 4th, plus b squared. If we square b, we get y to the 8th. And now this is factored completely.